Hey, what's up? This is I'm back and ready to start us off on chapter 6. Well, I just watched the video of chapter 5 and I had to watch myself and watch me hear my voice, and now I know you have to go through every class. I'm so sorry. Okay, but anyway, um, yeah, this is really good for practicing my own public speaking skills because I can watch how my explanations sound. One thing I thought was a little unclear when I was using the Neptune example to explain the principle of simplicity is this. When they saw when they detected the gravitational effects, they didn't say, "Oh, this is probably three planets and a monkey." That would just be unnecessary, right? Or they didn't say, "Oh, this is a big monster along with five planets and six planets." They just said one mass, because that was the simplest explanation for what would have caused um, that gravitational effect, and that's what it was: one big mass, one big planet. Okay, so principle of simplicity from the last chapter is go for the simpler explanation that posits fewer things. Okay, so better to believe in one necessary being rather than many. Okay, so I thought that was I could have done a little bit better with that explanation, and like I mentioned before, if you have like if there was anything that was unclear from the video, write that question down and bring it to class on Tuesday, um, or we can always talk about it in office hours. All right, let's go to chapter 6. Now, for chapter 6, a way to better understand it and to see it well illustrated is to watch the video that I sent that accompanies chapter 6. Okay, it's the fine tuning argument video. Okay, and so make sure you watch that. Watch the first few minutes. It just explains with illustrations much more clearly than anything I could just give you with my mouth, with my words. So if you haven't watched that, pause and watch it now. Okay, I'm gonna kind of hope that you paused it and watched it if you haven't already. Okay, so let's just talk through this some. Now we're going to be working through Chapter 6 handout. Okay, we're going through Chapter 6. We'll see how long this takes. I might split this up into two videos, and we'll go with it. We'll just go for it and see what happens. Okay, so what big picture is what we're going to be talking about is called the fine-tuning argument. And the fine-tuning argument is one type of design argument. Okay, so a design argument, sometimes called a teleological argument. That's the complicated word. If you want to ask in class why it's called teleological, ask them on Tuesday. But the easier term is design argument. Now, why is it called design argument? Because we look around and we see evidence of design, and then we infer that there's a designer. Okay, it's a very old argument, and it goes back, very many centuries. A lot of people think that Darwin, Charles Darwin, put an end to the design argument. So we used to think, hey, look at this. Something must have designed it. There must be a God that designed us, and that's why we are here today. Okay, you need an explanation for all of that. Um, well, through Darwin, we have an alternative explanation that doesn't seem to appeal to design. What we have is evolution, right? We can have an evolutionary process, okay, that takes simple organisms, okay, and you get random mutations, okay, and then from that, the fittest survive, and then you get further evolution until you get things as complicated and amazing as human organisms. I know that's way too big picture, broad strokes explanation of evolution, but a lot of you will have learned it in your high schools and or biology class. So I'm going to assume just a basic knowledge of evolution there. So the point is that a lot of people thought that the design argument was put to death by evolution, okay, or evolutionary theory by Darwin. Okay. But, okay, things have changed, and especially in the 60s and 70s and 80s, a new type of design argument came about. And it didn't appeal to the design of biological organisms. It appealed to the apparent design of the whole universe itself. Okay, it really looks like the universe itself might have designed, and it's really hard to explain how evolution could explain that. Okay, so that's what the fine-tuning argument's about, and very big picture. Okay, now let's go into the details. Why I think that the universe was designed? Well, first, it's things that physicists, astrophysicists started discovering as they learned more about the universe, as they learned more about the Big Bang, as they learned more about the initial conditions of the universe after the Big Bang. Okay, so Rhoda focuses his attention on the cosmological constant. And some of you might have learned about the cosmological constant in your physics class. If you didn't, well, I actually think Rhoda did a pretty good job explaining things just very slowly, very carefully. And even if at the end of the day you don't get it, what's going to matter, again, is the big picture. First of all, there's the cosmological constant and what's called the effective cosmological constant. What is that? Well, okay, first the point is the cosmological constant, it's like a variable or a factor where the higher the effective cosmological constant is, the faster the acceleration of the expansion of the universe. Okay, so right now most physicists think that the universe is expanding, and it's expanding at an accelerating rate. Okay, so expanding accelerating rate means it's the velocity is increasing at higher and higher rates. Okay, that's acceleration. So, that's acceleration. Okay, and if it's positive, it's expanding at an accelerating rate, and that's what the effective cosmological constant is. The effective cosmological constant could be a negative. Okay, so that means it might be still increasing, but the universe might still be expanding, but it's not accelerating. Okay, it's actually at some point it's gonna slow down, then come back on itself. Okay, so that would be for the effective cosmological constant to be negative. Right now, they've found that from what we know from the physicists is that the effective cosmological constant is about it's on page 101. It's 1.35 times 10 to the negative 123rd. So that's a very small number. It's 0.00135. Okay, I can't do. Okay, 135. Okay, you can see it in your own book on page 101. Okay, so that's what it is. Okay, and like I wrote on the handout, what's written on there is what I already explained about the cosmological constant being positive or being negative. Okay, and what we've and so that's what we have. It's slightly positive, so that means the universe is expanding right now, and it's actually accelerating in its expansion slightly at a very small number. Okay. Now, why do we care about all this? Who cares about how the universe is expanding? Well, here's what's really interesting. Okay? For the universe to be such that life could exist in it, and not just, but we mean the whole universe. We're not just meaning the Earth. We're not just meaning the solar system. We're not just meaning the Milky Way. We're not just meaning a bunch of the galaxies. We're meaning like all the galaxies, the whole universe. For the whole universe to have even for the whole universe to be able to have life in it, that cosmological constant has to be between two numbers, between negative 1 over 10 to the 120th power and positive 1 over 10 to the 120th power. So you can see that in the book here at the bottom of page 101, okay, in case you don't know where we are. Okay, it's a very narrow life permitting range, okay? And 1 over 10 to the 120th power is really small, okay? It's extremely small, and right now we have it in there at 1.35 times 10 to the negative 123rd. That meets it, so the universe can be life permitting, but if we're just a little bit outside of that range, this universe cannot support life. Okay, now why? Well, why think that? So a way to kind of help get your mind around it is think about this. If the universe were expanding too fast, okay, well, how do we get planets? How do we get solar systems? Gravity kind of grabs the hydrogen atoms, the helium the molecules, and so forth, and it kind of pulls them together, and then you get stars. Okay, but that comes about from gravity pulling things together. Okay, and from the stars you can get solar systems, you get galaxies. Okay, so um, okay, now with that in mind, if the universe is expanding too fast, then gravity won't be strong enough to bring together um, the hydrogen, the helium, the atoms, the molecules, and so forth, so that we'll be able to have solar systems, so that we'll be able to have planets, and so that we'll be able to have life. Okay? Um, or suppose that the cosmological constant was too weak and the universe wasn't expanding that fast. Then we will get the universe coming back and kind of collapsing on itself. And then once again, you're not going to be able to have life if the universe has collapsed on itself. Okay, so what we have is that the cosmological constant is just at that right bit so that the universe can permit life. Okay. Rhoda gives a nice little example with this silos example. So you imagine 10 silos with negative numbers and 10 silos with positive numbers. And in these, by positive numbers, they're ping pong balls, and the ping pong balls have numbers written on them. Okay, so there would be one ball with the number 1 written on it, one ball with the number 2 written on it, and so forth. And then in the negative ones, there would be like a silo where one ball says like -10, another ball says -1000, and so forth. Okay, and then so you have all 20 of these silos. Okay, what's the chance that if you were to draw a ball from each one of those silos? Okay, you go through all the silos and grab one ball out of all the numbers on those balls, and you get a number between -1, 0. That you get you add them up and you'll get either -1, 0, or 1. Okay, it'd be tiny, right? It'd be nearly impossible. That's how low the probability would be. Okay, and that's the likelihood that our universe would be able to support life. Okay, all right. So that's the cosmological constant, the beginning. Now, I've been using the word fine tuning. What does fine tuning mean? Okay, well, this is on the handout. Okay, x is fine tuned for life equals if x's value had been slightly different, then the evolution of life would have been impossible. Okay, so x is fine tuned for life equals if x's value had been slightly different, then the evolution of life would be impossible. Notice about this is a lot of theists are putting forward this argument, the fine tuning argument. Just to be clear about this, a lot of these theistic philosophers are actually totally fine with evolution. Okay, what they're trying to argue for God, not from stuff about biological organisms, as I mentioned before. They're kind of assuming evolution and then saying, hey, even to have a planet where evolution could happen, you need something like God. You need something like an intelligent designer. So that's how they're going to be arguing. So anyway, I just wanted to point that out about the definition. So that's what it is for something to be fine-tuned. Now, Rhoda pointed out how the cosmological constant is fine-tuned for life, but there's actually more than that. If you look at page 104 of the book, you get a lot of things were fine-tuned for life, like the strength of gravity, the strength of the strong force, which that's what holds the protons and neutrons together, strength of electromagnetic force, the strength of the weak force, etc. Okay, so you got a lot of things that seem to be fine-tuned for life, not just the cosmological constant. A bunch of things have to be just right. And the other part is it's not just some quack physicist that agrees with this. Okay, some people in our class have kind of complained about the fact that people could pick from one scientist or this scientist, this psychologist, this anthropologist, But right now, this is what the majority of physicists and astrophysicists working on this agree to. Okay, most physicists agree that the universe is fine-tuned for life. And you got this nice little list here: John Barrow, Bernard Carr, Brandon Carter, Paul Davies, George Ellis, Brian Greene. Brian Greene is an excellent writer. Let's see. You got Stephen Hawking there. You probably heard of Paul Hawking, and a lot of other big names that are pretty impressive. You can look at those. So this is not just like something only a few physicists are accepting. A lot of the physicists are accepting that the universe is fine-tuned for life. Okay, next. So what's the argument? And this is what we as philosophers care about, the arguments. Let's get the premises clear. Let's get the conclusion clear. Let's see if it's a good argument. And if you look at what he has on page 105, it's not really that clear what the argument is. Okay, so if you look on page 105, here's what you get. Right around here. If the universe were designed, it would not be at all unexpected for it to be life permitting. If, however, the universe is not designed, but is merely the product of some unguided physical process, then it is immensely unlikely that it would be life permitting, because the proportion of life permitting universes within the range of possible universes is so small. Okay? But what's the argument? Are we supposed to go, therefore, there's a designer? So here's how I tried to put it on the handout, right here. If there's an intelligent designer, then fine-tuning is likely, right? So you can kind of, well, if there were a fine-tuner, then we could kind of expect the universe to be like this, that to be fine-tuned. Premise 2, if there's no intelligent designer, then fine-tuning is very improbable. Okay, this is, by the way, I'm drawing this from the quote there. Therefore, there's an intelligent designer. I mean, this doesn't look like a valid argument. Okay, so I'm not criticizing Rhoda too much here yet, but it seems like Rhoda needs to give us a little bit more about what the argument is, and he's going to do that in the next couple of chapters. But right now, I just want to point out the argument isn't that clear. It's kind of like we see fine-tuning, therefore there's a designer. I mean, maybe we can put this into modus ponens. Maybe we could do it another way. So you think about that. How could we get from the facts about fine-tuning to God existing? It's not going to be as easy as you would think. Okay, so with that, that's the first part of Chapter 6. There's objections coming up, but why don't we stop it there? All right, so we'll talk about more of that in the next video. Excuse me. All right, have a good one. Good.